Identifying minerals. Streak is the color of a mineral when it is broken up and powdered, and this is commonly created by rubbing the mineral on a piece of unglazed porcelain called a streak plate. A lot of times I use sandpaper for this, if I can find sandpaper that has a really light backing on it, mainly because it's harder and it's more readily available. But you can use a streak plate is what you commonly would use, but sandpaper works as well. This can only be used on minerals that are softer than porcelain. Porcelain is a 7, sandpaper is a 9, so you can actually get streaks for things that are harder than porcelain. But if you use a regular streak plate, it will only leave a streak if it's softer than a 7. Usually white for non-metallic minerals. This is more reliable than color of the bulk material. So a lot of times you see the color, but the color is very unreliable. The streak is actually much more reliable. So it says, despite the fact that these pieces of hematite appear remarkably different, their chemical compositions are the same. Thus, the streak that each makes is the same color. So these are actually both hematite. The streaks are basically the same color, but the minerals themselves look completely different. This is very useful for identifying metallic minerals. Doesn't work too well for non-metallic minerals because, again, they're mostly white streaks. But hematite has a red and silver form, for example, and they both make a reddish-brown streak. So this is really good for identifying metallic minerals. So color is one of the most noticeable but least reliable characteristics of a mineral. So first thing you see, it's really easy to see the color, but it's also very unreliable. Color is usually affected by the presence of trace elements, which don't really change what the mineral is. Just having a few atoms of iron or nickel or something in there doesn't really change the mineral. Small amounts of elements mixed in with the crystal, again, those are your trace elements, will affect the color. So there are many different colors of quartz, for example. So you have red jasper, you have purple amethyst, orange citrine. Those basically all have different amounts of iron. So quartz, again, is silicon dioxide. But if we throw in some different amounts of iron, you can get amethyst or jasper or citrine. Rose quartz has some magnesium and titanium mixed in with it. Milky quartz has bubbles of gas and liquid trapped in the crystal, so it's really just silicon dioxide with some air bubbles in it. So color is not a very reliable characteristic. So some examples of quartz. You have jasper, we have amethyst, we have citrine, so which these again were all different amounts of iron causing this, and then you had some magnesium causing your rose quartz over here. So special properties. So we have several different special properties which sometimes only apply to a mineral or two, but they can be very useful. So double refraction. This occurs when a ray of light passes through the mineral and is split into two rays. So if you kind of see here, you have this grid behind this piece of calcite, but when you lay the calcite over it, you get a doubling of that. Okay, so calcite is a mineral that has double refraction. Effervescence occurs when reaction with hydrochloric acid causes calcite in limestone to fizz. So we have limestone, you put some hydrochloric acid on it, it bubbles, you know it's limestone. There's a few others that will do that, but limestone is your major one. The other ones are all forms of limestone. So magnetism occurs between minerals that contain iron, so only magnetite and pyrrhotite are strongly magnetic. So if you stick a magnet to it, it's going to be one of those two, if the magnet sticks to it. Iridescence is a play of colors caused by the bending of light rays. So labradorite has iridescence to it. So you move it around, it kind of changes colors. Fluorescence occurs when some minerals are exposed to ultraviolet light, which causes them to glow in the dark. Calcite's one example. Fluorite's another example. So some will fluoresce under black light. Texture describes how a mineral feels to the touch. And this is very subjective, kind of like the luster. The luster is subjective, especially the non-metallic luster is subjective. The texture is very subjective. It can be described as smooth or rough or jagged or greasy or soapy. So fluorite on the top is really considered smooth. Talc is considered greasy, but again, this it just depends on how you describe it. And probably best if you describe it with 2 or 3 different textures that might apply to it. Like it may feel greasy or it may feel soapy. It could feel both of these, or oily. Density and specific gravity. So density is a measure of the mass per unit volume. So density is mass divided by volume. So one way to tell, say, fool's gold from real gold, for example, is to get the density of it. So pyrite, which is fool's gold, has a density of 5.2 grams per cubic centimeter, while real gold is 19.3 grams per cubic centimeter. So there's a big difference here in these densities. So what that means is if I have two samples that are the same physical size, the gold is going to weigh about 4 times as much as the pyrite. The density reflects the atomic mass and the structure of a mineral. So for example, diamond, which is pure carbon, is 3.52 grams per cubic centimeter, and graphite, which is also pure carbon, is 2.26 grams per cubic centimeter. So it's not just the elements involved, it's the elements and how they are arranged in the structure, because both of these are pure carbon, but the graphite is less dense than the diamond. This is a useful identification tool because it does not depend on the sample size. Doesn't matter how big of a sample you have, you can calculate a density for it. Also, it is measurable and objective. So this isn't something that somebody has to describe a special way or whatever. It's not somebody describing a color or describing a texture or a luster or something like that. This is measurable and objective. Density is commonly measured using specific gravity, which is the ratio of the mass of a substance to the mass of an equal volume of water at 4 degrees Celsius. Well, at 4 degrees Celsius, 1 gram of water is equal to 1 milliliter of water. So what that means is at 4 degrees Celsius, water's density is 1 gram per milliliter. So in practice, what that does is it just makes this unitless. So we talk about 2.2 grams per cubic centimeter. Well, if we are in the metric system, it's the specific gravity is 2.26. If we talked about the specific gravity of diamond, well, if we're in the metric system, it's 3.52. Now, why do we bother calling it something different? Because if you're using the English system, you get different numbers. So if you're talking about ounces per cubic inch or something like that, then your numbers do change. So you would end up with different units or different numbers. But if you're in the metric system and you're doing grams per cubic centimeter, the number stays the same. You just get rid of the units. So then that allows you to do things with it that you don't have to worry about the units.